Hello children, Bindu is back. Previously, we learned about force, balanced forces, unbalanced forces, first law of motion and inertia. Now, without getting late, let us gather more information on momentum, second law of motion and applications of second law of motion. Before that, let us focus on the learning objectives. Learning outcomes. After studying this topic, you will be able to know momentum, second law of motion, acceleration. Keywords: momentum, second law of motion, acceleration. We know that a cricket ball is much heavier than a tennis ball. Suppose we throw a cricket ball and a tennis ball, both at the same speed or velocity. It will be found that more force is required to stop the cricket ball, which has more mass, and less force is required to stop the tennis ball, which has less mass. The force required to stop a moving body is directly proportional to its mass. Now, if we throw two balls of the same mass at different speeds or velocities, it will be found that more force is required to stop that ball which is moving at a higher speed, and less force is required to stop the ball from moving with less speed. The quantity of motion in a body depends on the mass and velocity of the body. This quantity is called momentum. The momentum of a body is defined as the product of its mass and velocity. Momentum is equal to mass into velocity. If the mass is m, velocity is v, and momentum is p. Momentum is given by p is equal to m into v. If a body is at rest, its velocity is 0, and hence its momentum is also 0. Every moving body possesses momentum. As momentum depends on the mass and velocity of a body will have a large momentum. If its mass is large, or if its velocity or speed is large, or if both its mass and velocity or speed are large. Momentum is measured in kilogram meter per second. A car or bus may not be running at a high speed or high velocity, but because of its big mass, it has a very high momentum which may hurt the person coming in its way. It is common that road accidents at high speeds are worse than accidents at low speeds. This is because the momentum of vehicles running at high speeds is very high and causes a lot of damage to the vehicles and injuries to passengers. When a cricket player catches a ball, the player delays catching the ball. The player, in doing so, avoids his hand getting hurt. The ball has momentum and delaying the catch decreases the ball's momentum. So, momentum can be decreased if a body's velocity decreases with time. As with time, body's velocity will decreases, and with that, force on the player's hand will decrease. This is an application of Newton's second law of motion. Newton's second law of motion says the change of momentum of a body with time is directly proportional to the applied force and takes place in the direction in which the force acts. Newton's second law is expressed as force proportional to change in momentum by time taken. Consider a body of mass m having an initial velocity u. The initial momentum of this body will be mu. Suppose a force F acts on this body for time t and the final velocity becomes v. The final momentum of this body will be mv. Now, the change in momentum of this body is, and the time taken for this change is t. So, according to Newton's second law of motion, F proportional to mv minus mu by t. Now, the second law of motion, the equation F proportional to mv minus mu by t can be expressed as, this represents the change in velocity with time, which is known as acceleration A. Using acceleration A in the equation, F proportional to m into A. The equation F proportional to ma can be expressed by putting in a constant k. The value of constant k in SI units is 1. The equation F is equal to k into m into A can be expressed as F is equal to m into A. Since force is a product of mass and acceleration, force is measured in kilogram meter per second square in SI units. The name for kilogram meter per second square is Newton N, named after Isaac Newton, who made the laws of motion. Newton's second law of motion gives us a relationship between force and acceleration. When a force acts on a body, it produces acceleration in the body. The acceleration produced may be positive or negative. The acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body. As the acceleration produced is inversely proportional to the mass of the body, it means that it will be easier to move light bodies having less mass than heavy bodies having large mass. Points to remember: the force required to stop a moving body is directly proportional to its mass. The momentum of a body is defined as the product of its mass and velocity. Every moving body possesses momentum. Newton's second law of motion says the change of momentum of a body with time is directly proportional to the applied force and takes place in the direction in which the force acts. When a force acts on a body, it produces acceleration in the body. The acceleration produced in a body is directly proportional to the force acting on it and inversely proportional to the mass of the body.